Hey, how's it going? It is Shaf, the Algo Guy. I am here with another video. It's been a while. It's April 2nd, 2024. And I think the last time I recorded something was like almost 2 months ago. But decided to get back on the train again and start recording. And we're going like right into it with machine learning, of course. So I'm going to be talking about something called Clip, which is a model that's, I guess, considered ancient now. It's something that OpenAI released, I think, in January of 2021 to do a lot of really cool things with image captioning and image segmentation. So you can use it to build an object detector to detect something that's within an image and caption it and label it. Clip uses the vision transformer architecture under the hood, which is a version of the transformer which many people are super familiar with anyway, as far as LLMs are concerned. All you LLM junkies and all those people who think LLMs are the only thing that AI is. But yeah, the transformer model is actually quite versatile, and it can be used in a lot of different things, including image processing and sound synthesis and a bunch of other things. So yeah, and just a little bit of history. The transformer model, for those of you who don't know, the vision transformer superseded, in some senses, the convolutional neural net, which was an amazing model which did a lot of amazing things as far as feature detection in images, and allowed image processing to essentially skyrocket in its capabilities. But keeping a long story short, the vision transformer does it in some cases much better. But that's not the end of the story, because there are versions of CNNs which are competitive with vision transformers these days too. So yeah, but what we're going to do today is not talk too much about the details regarding this on the machine learning level. I will probably save that for another video and a review of the paper, which Clip was introduced way back when. But what we'll do is we'll try to build an actual object detector with Clip. So the first thing we're going to do is we're going to install the transformer models from Hugging Face, which is the place where all transformer models in Python are pretty much obtained from. So, and Colab is where I'm at right now. Has this generative code completion. I could turn it off, honestly, but it helps me reduce my spelling errors. So, but I'm going to explain all of the lines. So the first thing we did was install the transformers. And now what we're going to do is we're going to mount our Google Drive, because my images that I'm going to detect the captions from are on Google Drive. So this is how you mount the Google Drive for those who aren't familiar. Okay, so now I can access files directly on my Google Drive. So the next thing is we're going to import some things we need. First, specifically, the most important things are going to be the Clip processor and the Clip model. Clip processor, Clip model. So the Clip processor is going to be the thing that allows us to take our image and our caption and kind of vectorize it so that we can actually do training on it with the Clip model, or we can do validation on it or detection on it. So yeah, it turns it into something that can be fed to the machine learning model through processing, and you'll see that. And then we're going to use the image. We're going to obtain an image, because I want to output the actual image that you see that I'm going to be obtaining from the Google Drive. Then we use PyPlot. We're going to use that to plot the thing, and we get torch, and then finally OS. Okay, cool. So the first thing we're going to do is we're going to get a reference to our image. So I'm going to call this my label path. The label is going to get, well, actually first we're not going to do that. First what we're going to do is we're going to get access to our labels. So we're going to use the ImageNet labels, the ImageNet 1000, I believe, which is a number of labels that were used originally in I think 2012 in the ImageNet competition, and then they've been changed over the years. But the labels are like categories of things that you would detect. So we need like things to actually associate in this version of Clip an image with. So that's what these labels are. And I downloaded them locally, but you can obtain them from GitHub. They're pretty readily available, and they're often used in machine learning applications and for machine learning competitions, specifically for images. So this is our labels, and so now we're gonna load our labels. So we got to, once we have our path, we can load our labels, and we're gonna put them in something I call captions. So to load the labels, we load them line by line. Sure. So we get rid of all the excess space. Read lines. Okay, and so this is how you read a line, each of the line by lines. So again, the file is basically a text file with a bunch of captions like chair, dog, cat. But the captions, are quite a few of them, actually, and so they're more nuanced than cat, dog. They're like different types of cats and things like that, and you'll see what I'm talking about. So what I'm also going to do is I'm also going to create 5 captions that are, I'll explain what these are, but these are much more broader categories, and I'm going to do that just for comparison purposes later. So these are like not very specific at all, right? These are animals and other objects at close to, one can think, like for example, boat at their highest taxonomical level. Actually, vehicle might be at the higher taxonomical level of boat, but that's fine. And so the first thing we have to do is we're going to actually run our model, and we're going to run our model, and we're going to get our model first, not run it. And we're going to get, it's a pre-trained model, and the pre-trained model is going to be OpenAI base patch 32. So there's different vision transformers. VIT stands for vision transformer. There's smaller ones, and then there's larger, more complex ones. The smaller ones are really pretty good for a lot of tasks. The larger ones are really, really good, but they come at a computational expense. So this VIT patch 32 with the training data that a clip was trained on is the one we're going to use. What the actual training data that clip was trained on actually hasn't been disclosed. It's actually millions and millions of images across the internet, and yeah, again, there's really I don't think it's been disclosed. I could be wrong, but I'm pretty sure, at least from when I remember a while ago it being used, it hasn't been disclosed. So once we get our images, then we're going to obtain an instance of our processor, or once we get our model, we're going to obtain an instance of our processor, and the processor is going to be used. Well, I'll show you. So we're going to obtain our image, and then this is our image path, right? So it's a PNG, not JPEG. You can use PNGs, you can use JPEGs, it's fine. And then we're going to get our image. So the image is going to be what we output to the screen on each iteration. And so we're going to show the image. So this is pretty straightforward. We take our image, we don't need the access because the image doesn't really need an access for our simple application, and we're just going to display that. And then finally, we're going to use our processor to convert our image captions into something that the machine learning model can use. So don't really worry about these other, so these are kind of like default arguments. So yeah. Okay, cool. So this is going to be our inputs are processed inputs. And again, we're using one image. We can use multiple images, but I'll just show you one image at a time. And so our outputs equals model dot inputs. So then we run our model against our inputs. This is where we're doing the actual, learning and the actual prediction. And then we're taking the output of our model and we're going to save this so-called logits per image. And so logits per image are the actual, it's the actual vectorized latent space data that's actually stored and embedded, and that we're using to actually, the machine learning model is using under the hood. So if you remember back to logistic regression, the output essentially is a logit, and that is something that's not interpretable by a person, right? Until we convert it to a probability distribution. And how do we do that? We do that through the use of an activation function, specifically softmax, if you remember. And so if we do logits per image, and lo and behold, softmax is predicted to be the thing that I type, because softmax is often used in machine learning applications to convert logits into probabilities. So that is a good just throwback to that. So the next thing we want to do, once we have our actual training and everything, we want to then we'll get a bunch of probabilities as the outputs, right? Like for each label, we'll get a probability essentially. What we want to do is we want to take the most likely labels, and so for that we'll just take the top 5. And so we don't need the top 5. We could take the top 3 if we want to get more specific. I'll go back to why this is here after we run our probability on all of the ImageNet labels. But so now that we have our top 5, we'll then put our outputs to the screen. So we'll just do this joint indexing to this label. I'm going to create a joint index, top probs 0 and top label. So this pairs the labels and the probabilities. So what we're going to do is we're going to print each of these. This was right, but we're also going to print a percentage because I want to format it nice. Otherwise, it's going to come out like a large decimal, which looks ugly to read. Okay, so now we're iterating through each of the outputs, and we will print out each input and a camera, or not a camera, we'll put out in a caption, okay, and I think this should be sufficient. So what we're going to do is we're going to run this now, and we're mounting our drive. And so I have an image of a cat saved up there. I can take other images. Let's see what I did wrong. Of course I typed something wrong. Oh, I thought I had an image of a cat up there. Oh, no, it's not under images. I think I just have it literally under cat. Let's see. I should put the install transformers in a separate line so it doesn't try to do that every time and take up more. Hopefully there's not too many more errors. It's coding. So it's running the model, and what you should see after all is said and done, if it ended up working right, which I always get anxious about the little red spinny on Colab, especially after it's already spent a lot of time doing some work, to whether it's going to make me lose more time. especially in machine learning applications. Oh, let's see what happened. Oh, great. So, okay, so firstly, it looked like it printed the cat, but it didn't print the labels. I think I might have messed up my label code. I'm going to change this a little bit. Captions, label, IDX. So instead of just printing out the label, I'm going to print out the percentage like this. Percentage to F. I'm thinking that might have been the problem. And then what I'm going to do is I'm going to move okay, I'm just doing that in advance, and then I'm going to run this again so it doesn't take up all that extra time. So run it. So I printed out that cat. That was a nice looking cat. In the meantime, let me try to get yet another cat image. All right, let me try a dog. Let me take a dog. And I'm going to just upload a dog image. So let's see. And I could do this with different cats, different dogs, etc. But let's keep this simple for now. And so look, it says that the type of cat, it outputted a bunch of different cats because these are the cats it got from the labels, right? Several different cats in the ImageNet labels. And so it thinks it's mostly a Madagascar cat, which I guess it's true. I think I've seen those before. But let's see what we do when we specify our labels. And we narrow out, or like broaden the categories of labels. And there you can see it thinks it's at least with 96% accuracy a cat. And it could be a mouse or a dog also. But let's try running it against the dog.png. But those are minuscule percentages of dog. 99.67% dog. And so, curious what it thinks is if it's a horse or a boat. Let's see. And I'm going to change my labels to 2. What does it look like more? It looks more like a horse than a boat, according to AI. Okay, well, that was just a fun little experiment. Okay, and so that's pretty much it. So if you want to learn more about the vision transformers and the clip models, I'll add some links in the description below. And if you like my videos, please like, subscribe, and I'll do more complicated things in the future. For instance, I will do more specific object detection, and I will try to do like moving image and object isolation using clip and some more advanced models as well, like Detectron. All right, well, thank you very much. Appreciate your time.